Thank you all for joining again. For those who are new to the Toronto Machine Learning Society and the MLOps World Groups, it's a community now of over 10,000 active members, and we're working to promote and encourage the adoption of successful machine learning initiatives within Canada and abroad. We started in 2017. We were seeing that there was a lot of misconception, I guess is a better word. Obviously, in the machine learning world, we're still in the early stages. But we said, you know what, we don't want all of the talent, all of the learning, all of the skills, all of the case studies, etc., to be in the hands of a few companies. And we did see some of the staple companies, at least here within Canada, Sears to mention, one go down, and they just couldn't compete with some of the other companies that were able to adopt to a lot of the more AI focused approaches from the top down. So, our goal is to help disseminate this information across our community, help democratize access to a lot of this information, and help link some of the research to successful use cases. And when we do this in person, it's also really fun because in the same room you'll have entrepreneurs, executives, machine learning practitioners, engineers, data scientists, and even researchers, right? So it's a lot of different people working within subsets of AI that wouldn't necessarily have access to each other. So it's a really fun time. I'm really looking forward to the in-person. Some of the benefits of these virtually is that you get to interact more easily with more people, right? So I'll get into some of the things that I hope for today, but one of which is ask a lot of questions. Please use a Chrome browser. I think that's the best. They may have made some advancements with the platform, so you might get away with some other browsers. But if you do have issues, I would say first things first, check your browser. If it's not Chrome, and if you have Chrome handy, try and use that. If you're accessing this from a cell phone or from a tablet, desktop or laptop is probably best. It will ensure you don't have any issues. And lastly, if you're accessing through your company VPN, sometimes they have security settings. That might also be an issue. So if you are having some troubleshooting issues, just check some of those items. As I mentioned, asking questions is kind of a key to these virtual events. They're not perfect. We have some hiccups often. So thank you in advance for your patience. But one thing that you can do is make sure to sort of be vulnerable and ask questions where possible, even if it's a little uncomfortable. The value you receive will be directly proportional to the questions that you ask. And that's important. That's something that we've learned throughout this past year, having done these now virtually for a year and a half. We hope you could stay connected with the speakers and some of the other people in the chat. So you can message them privately if you click on their name. In some cases, you'll be linked to their LinkedIn. So you can message them and contact them. Some of the speakers are really gracious in the time that they give, not only in answering questions, but afterwards. So if you wanted to ask a follow-up question or something and you had to leave the chat, or you just want to do it on your own time afterwards, feel free to request a connection on LinkedIn, so on. The speakers, in many cases, they make themselves available, and we're really grateful for that. Lastly, if you want to chat, make sure sometimes people in the chat sessions, they think that they're asking a question in that session, but they're actually toggled onto the main chat of the event. So it's a little confusing. Just so you know, you'll see at the top right, event, stage, session. Make sure you're in the session if you're asking a question specific to that session. If you just want to make a general announcement, you can make it on the event chat there. Okay, cool. Moving forward, if you're hiring or job seeking, or you simply want to network, you could change your profile and mention maybe where you're from, or your company name, and so on. You can do that by clicking on your profile. That makes it easier for people to contact you. Last thing, this is very important. I just want to give everybody a heads up. Some of the talks today will go over. That's okay, because sometimes we can't account for all the questions and we don't want to stop it short, right? So if some of the talks go over the allotted time, just be cognizant of the half hour or the hour, just in case there's something that you wanted to not miss the start of. So please don't rely on us to perfect, like to the minute stoppage so that the other one will start. The virtual rooms, they're going to go over, and the MC we've asked to give like a light heads up just so that you know. Some of the sessions in the other rooms will be starting. Feel free to leave if you'd like, or stick around as some of the questions continue and we will go over. A couple thank yous. Thank you to all the volunteers. Thank you to the committee In this case, Suhas, who I'm going to allow on screen in a second. He's been great in helping curate some of the content there, and can't say enough about all this hard work in putting this together. The staff, Tina, Jen, all of our members, Fraz, and the speakers as well who make this happen. They dedicate their time. They dip into their bag of tricks and share their work, and we're really grateful for that. And also you for coming out, everyone here that's coming out. I know it's not ideal. Some of these virtual events can be tough. People have Zoom fatigue, but we had a great turnout, and it means a lot that we could keep this going. So that being said, I also want to thank the sponsors. So UltimateML, they're serving as a bridge between cutting edge research and commercialization and industry. So they're hiring, they're doing really interesting cutting edge work. If you go onto Booth and then click on any of the companies, you'll see that there's $100 gift cards being given away. There's a really cool retro pair of, I believe, Nike shoes as well. And you'd be surprised how little people actually remember to go onto the booth and just click. It's just one click, and then you're registered in the draw. So I would encourage you to do that. TensTorrent as well. Thank you to TensTorrent. They've been a sponsor this year. They're really evolving the traditional chip design for machine learning. They have the famous Jim Kelly as the CTO. They have architecture that enables scalable deep learning. And if you click on their booth, you'll see a video and you'll see some information there. And they have some giveaways. I know that they're also looking for partnerships, whether you're in academia or industry. They're really looking for just some formal/informal partnerships. And they recently received a lot of funding, and they're interested in finding partners and people to learn from. So if you think that this might be interesting, feel free to get in touch. They're very available. They'll respond, and they're also very friendly people. So Data IQ as well. They do analytics at scale. They kind of take companies from an analytics stage to a scalable enterprise AI stage. They're working with some really big companies. They've been actually just apart from their platform itself, a wealth of knowledge. So their contributions have been really good. I encourage you to check them out. And lastly, Run AI. They do rapid AI development, and that's really what they're all about. So it helps to move, again, companies from doing pure research to a company with concrete, specific results in production environments. And they've been very, very helpful. They've got a really good track record of working with companies on that side as well. So if you want to check that out, they have the AI infrastructure stack of the future, and you can see on the website, it is pretty interesting. So I encourage you to check that out as well. Again, a click, you'll be registered. If you go onto the booth section on the left-hand side, you'll be all set, and you'll also be registered for the draws. So I encourage that. So I'm going to be back here as in a while. We're going to hear from Suhas. We're going to hear from Nils on this stage for our first keynotes. And then we'll be breaking off into the session tabs as well. I think that's it for me. The one thing I did want to mention is in November, we have our large 5-day conference, lots of workshops, 20+ hands-on, multiple hours, and then a lot of sessions. So if you have a chance, we'll be messaging afterwards just to give everybody a heads up on that. There is an open call for speakers as well. So if you have anything that you might be interested in, or even if you want to just get involved in general, you want to help volunteer, MC, speak, all of those things, shoot us a message. We always look for people to join us and participate. That being said, I am going to zip it and let the conference proceedings continue. I'm going to welcome to the start Suhas on stage to help us with some opening remarks. Suhas, welcome.
Hi, David. How are you?
I'm good, thanks. I'll let you get to it.
Okay, thanks, David. And hello, everyone, and welcome to the TMLS NLP conference. It's been a great experience helping set the agenda and the speakers for this event. In just a few minutes from now, the talks from our wonderful speakers will commence, which I'm sure you will leave with a lot of knowledge, wisdom, and food for thought. Before we start off, as someone who loves this field immensely, I would just like to take a few minutes to take stock of the difficult last couple of years, and from an optimist point of view, chronicle some positive developments that have happened in the NLP community during these challenging times. So the fight against COVID itself was fought on many frontiers, including on the NLP front. We saw the NLP community rise to the occasion by its work on the COVID-19 dataset, which is a large dataset of research papers and articles about the coronavirus, released in collaboration with White House and major research labs. The systems that were built on top of this dataset include like knowledge graphs for facilitating knowledge extraction, evidence miners that retrieve textual evidence in a corpus given a scientific claim, and even hypothesis generation tools for automated drug discovery. So at the forefront of these developments was the Blender Lab at University of Illinois, Urbana-Champaign, whose director, Professor Heng Ji, is joining us today for a talk on information surgery. What does information surgery mean? You have to stay tuned to find out for that. So I think we can all agree that on the data side of things, have generally not been given the primacy that it deserves in our field. Our field can sometimes get carried away by chasing leaderboards. However, the tide seems to be turning in the last couple of years. More attention is being paid to data-centric AI. Data sheets are becoming more common in model release specifications. People in general are putting more thought about the characteristics of the data that goes into training language models. So a common discussion point involves determining whether we should model the world as it is, with all the biases, etc., present in it, or the world that we wish to see. Anna Rogers, postgraduate researcher at the University of Copenhagen, is at the forefront of these discussions. And she's going to give a talk today on data curation for language models and emphasizing how the curation is kind of already happening, whether we like it or not. We are living in the era of large transformer-based language models that are so gargantuan in size and scale that only billion-dollar companies can build and control their access. This is, of course, a serious barrier towards the democratization of NLP. But the silver lining here in the past couple of years has been community-driven research organizations like Eleuther AI, who are the creators of the open source GPT-Neo and GPT-J language models. Similarly, it's very impressive to see Big Science, a large Hadron Collider-style mega collaboration project involving hundreds of researchers across the world who are aiming to train a very large multilingual language model on a supercomputer located in France, at the same time performing valuable research in the area of bias, ethics, data governance, and other forms of social impact. So as the deployment of language models in the real world becomes more widespread, security and privacy issues have come to the fore. It has been shown that language models, for example, they memorize training data, and then they can be prompted to emit those private information. And then you can have things like input data poisoning and training data poisoning that can enable adversaries to force undesirable predictions. And from the privacy side of things, it has become critical for model owners to provide privacy guarantees for user-provided training data, inference data, and also model output data. And in recent years, you have had privacy-preserving machine learning techniques like using differential privacy, secure multi-party computation, and homomorphic encryption. So Patricia Thine, the CEO of Private AI, will be giving us a talk today on some of these techniques and how they can be employed in service of privacy-preserving NLP. The transformer architecture that underpins all these language models have been successfully disrupting even other fields, like, for example, recently speech and also vision. But more closer to home, they have found widespread acceptance in the field of information retrieval and text ranking. Modern text ranking methods make heavy use of BERT-like models, either standalone or as part of multi-stage architectures, along with traditional algorithms like BM25. Nils Reimers, NLP researcher from HuggingFace, will be giving a talk on the latest developments in neural search as the part of the keynote, which is coming next. He's also the creator of SBERT or SentenceBERT, which is my all-time favorite NLP library. and what I personally call it as the Swiss Army knife of NLP. So next, the few shot or zero shot paradigm that has taken over NLP in the past by storm, basically in the past couple of years. But performance-wise, I think it still leaves a lot to be desired. So fine-tuning models still remains like the de facto way of using language models for specific tasks. Recent developments in this in fine-tuning include like task or domain adaptive fine-tuning, tuning only specific subset of parameters, pruning parameters, etc. Armen Agajanian, research scientist at Facebook AI, will give a talk on recent developments in this field. Lack of large-scale data, especially label data, is often a hindrance that limits people from effectively employing NLP techniques. So there has been a lot of work in this area in recent times, including in domain data augmentation, semi-supervised learning, etc. Yanshuai Kao, senior research lead at Borealis AI, will be giving a talk on these topics, including on how to train deep transformers for tasks involving reasoning, even when you have very little data, with text-to-SQL semantic parsing as a case study. And if you want to learn more about semantic parsing, we also got a talk for that. Federico Fancello, senior research scientist at Samsung AI, will be giving a talk on semantic parsing and also an overview of the state of the art in that field. So all the advances in this field, they are promising, but when the rubber hits the road, when things are put in production, and then models put in production face unique challenges, always contending with things like, concept drift, domain drift, etc. They are definitely not your friends. Rachel Tatman, senior developer advocate at Rasa, will be talking about testing, validation, and evaluation of NLP models, especially in production, using chatbots as a setting. And then last but not the least, we'll also have exciting talks from Jerome Messo on knowledge extraction in the field of geosciences and how to work when all you have is limited domain-specific data. And Laureano Moro Velasquez, assistant professor at Johns Hopkins University, will be giving a talk on using NLP techniques to evaluate the language of patients with neurodegenerative diseases like Alzheimer's or dementia. So that's such an exciting lineup, and I hope you're all as excited as me as well for the talks. So with that, we'll commence with the keynote shortly. Thanks.
Okay, and thank you so much, Suhas. I really appreciate that, and that's a good little recap and broad stroke coverage of what we have here today. It's really nice, and again, you did a great job of putting this together, so thank you so much. I really appreciate that.
Thanks.
Yeah, next we're gonna welcome on to the stage Nils Reimers, and I'm just going to allow Neil in and read through his bio here so you have an opportunity to get to know Nils. Nils, how are you? Thank you so much for joining.
Yeah, thank you so much for having me here.
Yeah, absolutely. And for those who are not familiar, before I pass it over to Nils, Nils has been doing some incredible work after finishing his PhD. Just as a bit of a primer, Nils worked as a postdoc at UKP Lab in TU Darmstadt on the topic of representing text in dense vector spaces, which enables many applications in the areas of clustering, topic modeling, semantic search. And as part of his research, he created this sentient transformers library, which allows the easy usage of training of such methods. So since May 2021, he has worked as a research scientist for HuggingFace, which I'm sure most of you are familiar with HuggingFace, investigating how these methods can be further used to improve and be improved and be used in the context of gigantic language models. So I'm excited for this. Thank you so much, Niels. I'm going to pass it over to you. If you have any questions, folks, you can throw them into the chat here and we'll keep an eye on those. But with that being said, Niels, over to you.
Great. Yeah, thank you so much for the invitation. Today, I'm happy to present an introduction to recent developments in neural search. So this is an introduction talk. If you're interested in more detailed information on this topic, you can also check out my YouTube channel. They have a lot of different talks which go a lot more deeper in the topic. As you probably have known or noticed, there's quite some hype about neural search. But why is all the hype and why now? So this is a real example from Simple Wikipedia. So Simple Wikipedia has just 170,000 documents, and the query is quite simple. So the user asks, what is the capital of the United States? And if we take a look at lexical search using Elasticsearch and BM25, the top 3 hits are completely useless. So the first hit is the capital punishment. It mentions a lot about capital and United States, but it does not mention what's the capital of the United States. Second entry is about Ohio, because it also mentions states, United States, and capital. And the third entry is Nevada, also mentioning United States, states, and capital. So from all these 3 hits, the user gets no answer. So it's really unhappy about the results. However, if you contrast this to neural search, to an out-of-the-box model, these are the top 3 answers. The first is about Washington, D.C., correctly answering what is the capital of the United States. Second entry is about capital city and the definition of capital city. And the third entry is about the United States Capitol. So maybe the user mistyped capital and wanted to have information about Capitol. So the results you get from neural search is so much better than you get from lexical search. And that's why all the hype. You can also put this into numbers. So if you're more a numbers guy, here's a nice chart from Track Robust 04. That's a quite old information retrieval benchmark from 2004. And we see here the black line, this is the best system from 2003. And as you have seen, there was like no consistent improvement over the years. So basically, even after 10 years, there was like not really a system which was better than the system we had in 2004. But this changed in 2019 when there were like the pre-trained transformers based on BERT. We saw a significant improvement without having it specifically tuned for this benchmark. And that's why there's all the hype, because neural search is so much better than classical lexical search. There are a lot of different architectures proposed. In this talk, I can sadly only cover 4 architectures. I will talk about bioencoders, cross-encoders, doc-to-query, and Colbert. But there are a lot more architectures available. And also, every month, a new architecture pops up. And it will be interesting in the future which architecture will dominate and be the best. So bioencoder works on dense vector representations. The idea is you have your documents, you put them in the vector space, and then some query arrives like, what is the capital of the United States? You also put it in the vector space, and then you check what is the closest point in the vector space. More technically, you create it like this. So you have your document, you pass it through a transformer network like BERT, you apply some pooling, for example, mean pooling, you get some vector. So these are all the blue dots you see in the vector space. And then when the query arrives, you pass it also through BERT, apply some pooling, get some vector, and then you compute the cosine similarity. And the document with the highest cosine similarity, which is the closest in the vector space, is the best match for the query. Bioencoders have really nice properties in contrast to lexical approaches. First, it can overcome the lexical gap. So when you have Elasticsearch, and then the words US, USA, United States, they are all distinct. So if you search for United States, it will not find any entry where it mentions US or USA. Also, it respects the word order. So in lexical search, if you search for visa from Germany to Canada or visa from Canada to Germany, it does not matter, it's the same query. However, for bioencoders, and notice there's a difference if you want to go from Germany to Canada or from Canada to Germany, and will fetch the correct documents based on the direction you want to go. Also, if you work with bioencoders, they know about related terms. So for example, you're searching for Spearman correlation in NumPy, how to compute the Spearman correlation in NumPy. However, there's no such function in NumPy, but it finds an entry that there's a function in SciPy. And it knows SciPy and NumPy is quite similar. It's both based on Python. So it gives you the result Spearman correlation in SciPy. It's not limited only to text search. It also works perfectly for multimodal. For example, you can encode images in the vector space, and then you have your query, 2 dogs in the snow. And it finds the picture of these 2 dogs in the snow. And you can also do it multilingual, so it's not limited to English. So you have a multilingual text encoder, and independent, if you write your query in Spanish, Chinese, German, French, it will find the correct image of these two dogs. How to train these bioencoders? In principle, it's quite easy. What you need are some positive pairs. So for example, you have a question and an answer, or you have an image and an image caption, or you have a paper title and a paper abstract. And what you want is you want this pair, this positive pair, close in the vector space. So you want A1 and P1 be close in the vector space, while A should be distant, far away from all the other passages or the other P's in the vector space. The intuition behind that is that it's quite unlikely if you randomly select, for example, a question and answer, that they match. It's really low probability. Computing this is quite easy. So if you're familiar with how to train neural networks, it's just standard cross entropy. So given A1, so you have your, for example, question, you look for the right answer out of all the possible P's. So you compute the score between A1 and P1, A1 and P2, and A1 and P3. And you say, okay, my cross entropy loss, my gold label is 1, 0, 0. So P1 is the correct answer for A1. And then you just do back propagation on your network. How to improve the model, how to get better results. The most simple trick is to increase the batch size. So here we have a plot, how large is your batch size. We start with a batch size of 128 and go up to even 16,000 batch size. And here we see the performance on a popular benchmark. And as you see, the performance increases the larger the batch is. This is quite intuitive. So assume you have a multiple choice test, and there's a question, and there are like two options. Option one is you have 10 answer possibilities. The other option is 1,000 answer possibilities. Getting the right answer out of these 1,000 possibilities is a lot harder than when you just have 10 answer possibilities. The other trick to improve the quality is to work with hard negatives. So that's the red line. As you see, as soon as we train with hard negatives, the performance increases quite a lot. So what are hard negatives? Previously, we had these positive pair, like a question and answer. Now we have we have triplets. So we have our question, we have our positive answer, and we have our negative answer. And the negative should be similar to the positive, but it should not match with the anchor, with the question. So a bad example would be the following. So you have the question, how many people live in London? You have the positive, around 9 million people live in London. And then you have your negative, London has a population of 9 million people. This would be a bad example. So this would be a bad negative, because this negative would actually be considered as relevant by a human for this question. And by training, we would put A and P close in vector space, but A and N far away in vector space. So this would harm the quality of the vector space. A better example would be the following negative. Around 1 million people live in Birmingham, second to London. So this also talks about people living in UK cities. It also talks about London, but it does not provide the answer to the question, how many people live in London. Getting these hard negative, there are a lot of tricks and techniques how to get these hard negatives. If you're interested, check out my other YouTube videos where I explain in more detail how to get really good hard negatives and how to ensure that you do not get any bad examples and only good examples. The other architecture, which is quite popular for neural search, is our cross encoders. They work in the following way. So you have some search query or question. You have a first stage retrieval, which can be a bioencoder, what we've seen previously, or it can also be standard lexical search. And then you retrieve some candidates, for example, 100 candidates, and you pass it to a cross encoder, which looks at the query, looks at the 100 candidates, and computes a score for every document. And based on the score, you create a ranked list and output to the user, say, okay, these are the top 10 scores based on the cross encoder. Cross encoder works in the following way. So in the bioencoder, we passed the query and the document separately through the transformer network. Now we pass both as one input through the transformer network. So we have first the query, then we have the document, and then we perform cross attention between all the query words and all the document words. So every word in the query is checked and compared to every word in the document. And at the end, we get some score, which outputs how relevant is the document for a given query. The advantage of a cross-encoder is that it achieves much better performances. So here we see in red the cross-encoder performance, higher is better. And here we see in blue the bi-encoder performance. And as we see, the cross-encoder is a lot better than the bi-encoder. And especially when you go to fewer training examples, we see much better performances with the cross-encoder. So the cross-encoder achieves better performances, it needs less data, and it's also more stable to new domains. But the cross-encoder also needs a first stage retrieval. So if you use BM25, you still have issues with the lexical gap. And the biggest disadvantage of the cross-encoder that they are quite slow. So bi-encoder, it's really fast. So you can do a search in 15 milliseconds. With the cross-encoder, you have to wait half a second. And this is really, nothing you want in search, that you have like a really slow search function. So what you want is a fast search function, but a good search function. The third architecture I would like to present is doc-to-query. The idea is that you have some input document. So this is some passage you have, and then you have a sequence-to-sequence model, for example, a T5 model. And the T5 model predicts what are possible questions or queries people could ask about the passage. So you give in the document you have, and then it generates a lot of queries and questions people can have about this passage. And you concatenate these. So you have first your original document, and then you add 40 different questions you generated for this document, and you just index it into your standard search engine, for example, Elasticsearch. And you do just standard lexical search based on that. The nice advantage here is that you do not have any overhead at inference. So you can still use your standard search engine, Elasticsearch, for example. It's really fast at inference. And it can also overcome the lexical gap, because sometimes it produces synonyms like US, USA, United States, which are all concatenated to the document, but it does not respect the word order. The final architecture I want to present is Colbert. It's also based on the dense architecture. So in a bi-encoder, we had our query and document independently, and both were mapped to a single point in the vector space. In Colbert, the query is mapped to many points in the vector space, so every word is mapped to a point in the vector space. And also in the document, every word is mapped to a point in the vector space. And then you do a many-to-many comparison. So you compare every word from the query to every word in the document, and you create a final score. So far, I said neural retrieval is really great. However, there are some downsides. First, they were trained with really large data sets of 100,000 pairs and more. However, not so many people have 100,000 training data sets. So it's only suitable for big companies, or if you already have a popular product, but new companies, academics, or niche use cases are often left out. So we in our research asked, like, how well do models generalize to new domains? So can I take some out-of-the-box model and apply it to my really specialized domain? And the second research question is how to improve without having labeled data. What we created is SPEAR, the benchmark for information retrieval. We selected a lot of different tasks and 18 data sets on information retrieval. It can be that we want to retrieve, for example, news, or we have like a news article given and we want to retrieve tweets discussing those news articles, or we have some argument given and we want to find some counter arguments. So we have a really diverse set of information retrieval tasks, and then we tested a lot of different architectures and models to see how well do they generalize to domains where you do not have any training data. So can I take some model trained on Wikipedia and use it to retrieve tweets? What we see here is the performance and how often they are better than BM25 lexical search and how often they are worse than lexical search. What we see is that the cross-encoder is in most cases quite strong, is in most cases better than standard BM25. Also, doc-to-query and Colbert also performs quite well. Bi-encoders, in contrast, that really depends on the task. So if your domain and the task is similar to what they were trained on, they can improve. and give really good results. However, when there's like a big difference in your domain and task, you often see quite poor results. To do a little teaser about an upcoming project from us, which is Project Infinity. So improving neural search is quite easy. You just take a larger model. This is better than a smaller model, or you take a cross-encoder. This is better than a bi-encoder. However, larger model and cross-encoder, they are both really slow. So instead of optimizing the architecture and the model, in Infinity, we optimize the inference time. So this is a containerized solution which you can run on your cloud or on your on-premise hardware. And you get inference times, which is 2 or 3 times faster than standard HuggingFace transformers inference time. So you can run a BERT inference on a GPU in 1 millisecond and on a CPU in 4 milliseconds. And we will release this in September 28th. So if you're interested how to deploy an optimized solution on your hardware, sign up to the video, which is upcoming next week. Also, if you have not done yet, I can recommend to visit SBERT, SentenceBERT, or Sentence Transformers. It's a framework where you can train your own models for neural search. You can train bi-encoders, you can train cross-encoders, or you can also use one of the 200 pre-trained models. You can also find training data sets with over 1 billion annotated pairs, sadly only so far in English. If you work in languages other than English, there are also different models available for 100 different languages. You find tutorials. And also, if you're interested in the topic, feel free to follow me on Twitter or LinkedIn. So my research focus is domain adaptation, low resource, and multilinguality for search. So how can we make these systems, neural search, better, require less data, and be more robust, and work also for other languages than English? Thank you very much for listening.
Okay, thank you so much, Nils. I'm not sure if you can see, if you go on the right side of your screen, there's the event tab and some questions here. You want to check those out, or if you want, I could read them out to you.
Yeah, maybe that.
Sure. So Kunal asks how the training data schema looks like for the bi-encoder versus the cross-encoder.
Yeah, so basically the training data scheme looks the same. So for the bi-encoder, you need positive pairs. For the cross-encoder, you also take positive pairs. And then for the cross-encoder, you sample some negative pairs. So for example, you run BM25 to find similar entries, and then you take them as negatives.
Great. Thank you. And then Chengian asks, what do you recommend to companies who have less than 100K pairs of training data then? Is it using lexical search and compile training data in the meantime?
Oh yeah, that's a good question. We're currently investigating. So there's an upcoming research project and paper on this, like how many training pairs do you need? It depends a bit on your task. So maybe you can first check out if they're like similar models which perform well. So for English, we have models trained on, like, as mentioned, 1 billion pairs. So this is from all the domains, medical to online gaming to, I don't know, gambling to programming. So there they work quite well. If you have like language other than English, it gets a lot harder. And also when you have like really specialized domains like clinical nodes, then it can make sense to run lexical search and compile the training data, for example, by logging user interactions, what are they clicking, what are they reading, and then based on that, you collect training data and you can create bi-encoders. What you can also do is to combine it. So it's a called hybrid approach, where you run lexical search and bi-encoder search, and then you merge both results, which also gives quite nice results.
Thank you very much. And the paper that you mentioned that's being worked on, do we have a date for that and where we might be able to find that?
Sadly, no date. So the research project started 2 weeks ago. So it's really recent research project. The best thing is just follow me on Twitter. So there I will post it. And also in the meantime, I don't know, you can also always ping me and ask me, okay, what's the progress? What's the newest insight on this?
That's great. Thank you so much. Nils, thank you. This has been great. I know we're just sort of warming into the questions, so we'll give everybody a bit of a breather here before we kick off with the separate sessions in about 10, 15. So yeah, if you want to go onto the booths, you can check out the awards that we'll be giving out. But Nils, thank you so much, and congrats again. You guys are doing fantastic work. I know you're really pushing the frontiers of the space, so it's very awesome to see. Oh, we have one more coming in. Curious if there's any data augmentation method for NLP, or is data collection still pretty much manual?
Yeah, there's a nice GitHub repository which is called NLP org for NLP augmentation, which provides different data augmentation strategies, like, I don't know, creating typos, creating OCR errors using back translation. So you translate English to, I don't know, French, and then back to English, where you use a BERT model to create augmentation. But the improvement is not so big, in my opinion. These transformer networks, they have been trained on a lot of data, and they're often quite stable. So data augmentation is not really critical, in my opinion, for many use cases.
That's great. Yeah, no, that's really makes sense. If anybody has put your last questions in. Sometimes they come in a little slow. Otherwise, as Neil mentioned, you can send him a quick ping, connect on LinkedIn, follow him on Twitter, so that you can get up to date with any announcements. And okay, Simon asks, hey Simon, have you worked on classifiers for neural IR, prediction document clicked, when sufficient data is present? If so, which approach to use, or how best to combine the two?
Yeah, these are like the two different ways how to annotate data. Either you do it manually, where you say, okay, this is the input query, this is a relevant document, so you ask a human to do this, or you can also get it from clicks and interaction logs from users, where you see, okay, the user clicked on the second hit, and then he read the document, so you assume this was a good hit. So in principle, it does not make a difference if you ask users to annotate what's relevant, or if you derive it from the click logs. However, from click logs, working from click logs itself, it's like a science in itself, because you never know what people do. I don't know, maybe they click on the second link and then they get distracted, and you misinterpret this as a relevant hit. So there, it's quite important to have like quite a lot of click logs and quite good method to derive what's relevant and not. And if you have this approach, when you know from your click log what's relevant, you can train any of the methods like doc to query, cross encoders, by encoders. So it does not matter what to do.
Simon says, to clarify, there's many different ways. Difference is that you are directly predicting a doc ID using softmax rather than learning a vector.
Okay, so do you predict the doc ID from all the possible documents, or do you do it like in a cross encoder? Do you do it in a re-ranker?
Yeah, we'll give Simon a section to clarify. Reg, in the meantime, is asking, are there libraries of test data for certain areas?
What do you mean with test data for certain areas?
Maybe you could clarify there, Reg? And Simon says, yes, very large softmax.
Yeah, there was one from, I think, Amazon, one paper which proposed a system where they do have like a softmax over all the products of like 1,000 millions of documents, which also work quite well, where they use some tree structure to prune it and to predict which document is relevant. So in the paper, they said it works quite well, but I did not do any experiments on that.
Interesting. And Yadi is asking, what is a good way to handle large text / documents?
Yeah, so handling large text and documents is still a challenge. In transformers, we have a limit of 512 tokens. So the most standard way is to break down your documents. So if you have a long document, I don't know, maybe 100-page book, you break it down to paragraph, or you break it down to snippets of, I don't know, 100 tokens, 200 tokens, 500 tokens. And then you treat these passages individually. So you do not search your 100-page book, but you break it down to, I don't know, 10,000 passages, and you search through these 10,000 passages and say, okay, this passage is relevant for the query.
Yeah, thank you. And great question, Yadi. people have either tackled that or have been wondering how to wrap their heads around that. Reg is asking, so just to go back, any example or I guess staple perhaps test data sets for certain areas, like for example, demographics or psychographics. I know we've sent some out just on social media, but perhaps Nils, do you have any that have stood as sort of go-tos?
Sadly not. I mean, data sets is still a big limitation factor, especially for search. We have only like really few data sets we can test on, and no more fine-grained where I don't know, want to take demographics into account, origin of a person. So yeah, there's a big need for better evaluation data sets.
Background noise, so apologies. Simon, thank you for posting that survey paper. That's interesting, and we'll hold on to that link. All of the links as well and things that we mentioned we'll be supplying back as we provide the videos afterwards. So you'll have a reference point for some of these discussions and links that we throw out. But yeah, I think that's good. We'll be taking maybe about an 8-minute break before we head into the sessions. The session tab on the left, you'll see some of those populate roughly 5 minutes before the talk. So if you don't see all the talks on the session tab, they will be populating a couple minutes before the session itself. Nils, thank you again. I really appreciate your patience and hanging around to answer some of these questions in this virtual setting. I hope you enjoyed it, and I hope this isn't the first time we see you.
Great, thank you so much, and yeah, enjoy the summit.
You're very welcome. Thanks, Nils. And thanks, everyone. We'll see you back here in a couple minutes.